Assalamualaikum and good afternoon to our lecturer, Dr. Masita at Masila Abdul Jalil. We are Group 9 from subject CSF3304, Computer Organization and Architecture. Today we are going to present our group assignment titled No Memory Traces, Influence of Mapping for Different Cache Size. Our representative for today is Nur Shafila Hanim binti Saharuddin, S59954, Nur Shakira binti Azian, S58482, and Nur Aida binti Isa, S60345. For introduction, a CPU cache is a hardware cache that lessens access time to information in memory by keeping some piece of the often utilized memory of the fundamental memory in a cache of more modest and quicker memory. The performance of a system depends on the performance of all individual units, such as execution unit like integer, floating point, I/O units, bus, cache and memory systems. The basic segment in most high-performance PCs is the cache. Since the bridge exists to connect the speed hole, its performance estimation and measurements are significant in planning and picking different parameters like cache size, associativity, replacement policy, and so forth. Cache performance relies upon cache hits and cache miss, which are the elements that make requirements to system performance. A cache hit is when you look something up in a cache and it was storing the item and is able to satisfy the query. The cache miss generally is when something is looked up in the cache and is not satisfied. The query is not found, means the cache did not contain the item that being looked up. The hit rate H is the fraction of memory access that are found in the cache, and the miss rate is 1 minus H. The fraction or percentage of access that result in a hit is called the hit rate. The fraction or percentage of access that result in a miss is called the miss rate. It follows that hit rate plus miss rate equals to 1, which is 100%. Miss rate can be decreased by evolving cache size, block size, and associativity. The initial step to diminishing the miss rate is to comprehend the reasons for the misses. The misses can be deleted, compulsory, capacity, and conflict. Compulsory miss is also known as first reference misses. These misses occur when the first access to a block happens. Block must be brought into the cache. Next capacity miss are misses that occur when the program working set is much larger than the cache capacity. Since cache cannot contain all blocks needed for program execution, so cache discards these blocks. Conflict miss is also known as collision misses or interference misses. These misses occur when several blocks are mapped to the same set or block frame.
Simple Scalar is a C-based simulation tool that models virtual computer systems with CPU, cache, and memory hierarchy. Simple Scalar is a set of tools through which users can build modeling applications that simulate real programs running on a range of modern processors and systems. When you read through this section, take note of three things. With SimCache, you don't specify the size of the cache directly. Instead, you specify the number of lines, the block size, and the associativity of the cache. The size of the cache is the product of these three numbers. Thus, a four-way set associativity cache with 1024 lines of 16 bytes each is 4 times 1024 times 16, which is 256 kilobytes. The cache to be configured is mentioned twice on the command line. The parameters to SimCache frequently use both 1, the numeral 1, and L, a lowercase letter l. Watch carefully because the difference in between the two can be subtle. An n-way set associative cache reduces conflicts by providing n blocks in each set where data mapping to that set might be found. Each memory address still maps to a specific set, but it can map to any one of the n blocks in the set. Hence, a direct map cache is another name for a one-way set associative cache, and is also called the degree of associative of the cache. This figure shows the hardware for a C-8-word and 2-word set associative cache. The cache now has only S, 4 sets rather than 8. Thus, only log24 2 set bits rather than 3 are used to select the set. The tag increased from 27 to 28 bits. Each set contains two ways or degrees of associativity. Each way consists of a data block and the valid and tag bits. The cache reads blocks from both ways in the selected set and checks the text and valid bits for a hit. If a hit occurs in one of the ways, a multiplexer selects data from that way.
Based on the question given, this is the result that we made for the different mapping. So here I am discuss about the 4KB and in different mapping and different view evolution such as multiprocessor and cache. So here is the result of the misses rate graph. If you can see, the graph will be decreases if the set associative mapping increases, and based on multiprocessor and cache we can see the graph will be decreases. The graph of misses rate will decreases. Okay, if you can see, if the number of block is increases, the graph of the misses rate will be decreases. So here is the full result of the misses rate graph. That if you can see, the rate of the graph will be decreases as the set associative increases. The misses rate will be decreases.
Discussion of task. For question 2, the question is, does the miss rate increase or decrease as the associativity increase? Why? What does it happen with the conflict misses when you enlarge the associativity grade? The answer for question 2 is, as associativity increase, miss rate decrease. This is because it can help to reduce conflict misses. The higher the associativity of cache, the lower the miss rate and the higher the delay. The higher delay is due to extra multiplexer that are used to implement associativity within sets. By providing n blocks in each set where data mapping to that set might be found, and we set associativity cache reduce conflicts. Each memory address still maps to a specific set, but it can map to any one of the n blocks in the set, and is also called the degree of associativity of the cache. The question for number 3 is, does the influence of the associativity grade increase or decrease as the cache size increase? Why? Answer for number 3 is, the influence of the associativity decrease as the cache size increase because a larger cache will have lower miss rate. And for the last question, does the increase of associativity improve the system performance? If the answer is yes, in general, which is the step with more benefits from direct to two-way, from two-way to four-way, from four-way to eight-way, or from eight-way to fully associative. And the answer for number 4 is yes, the higher increasing degree of associativity can improve the system performance. Larger set and higher associativity lead to fewer cache conflicts and lower misread. In general, two-way to eight-way set associative cache stack a good benefit between lower misread and higher cost.
In conclusion, cache memory is used to minimize the average time it takes for the main memory to access data. The cache is a smaller and quicker memory that holds copies of the data from the main memory locations that are often used. In a CPU, there's many different independent cache which hold instructions and information. The goal of this research is to influence the mapping of different cache size. In this, if the cache increases, we will check the graph of the misreads of the different cache if it increases or decreases. Other than that, the relationship increases. We heard that decrement would occur. And that's all from us, Group 9. Thank you.